And here we are on the final example of the differential equations packet, example 27, and there's quite a bit to this one. So consider the differential equation, dy dx is equal to 4x times y plus 2 cubed. And again, note, because this is a product, this is separable. Find the particular solution with the initial condition f of 0 is equal to negative 1/2. And then find the domain of the solution. So let's go ahead and work this problem out. We're going to divide both sides by y plus 2 cubed, multiply both sides by dx. So I get 1 over y plus 2 cubed dy is equal to 4x dx. Let's go ahead and bring that up and just write that as y plus 2 to the negative 3 dy. And let's antiderive both sides. So I get y plus 2 to the negative 2 over negative 2 equals 4 times x squared over 2 plus c. So on the left-hand side, I get negative 1 over 2 times y plus 2 squared equals, the 4 cancels with the 2, giving me 2x squared plus c. So let's take a look. When x is 0, y is negative 1/2. So we'll sub those values in. So I get negative 1 over 2 times negative 1/2 plus 2 squared equals 2 times 0 squared plus c. Let's handle the easier side. 0 squared 0 times 2 is 0 plus c is c. Down here, negative 1/2 plus 2 would give me 3/2. 3/2 squared is 9/4. 9/4 times 2 would give me 18/4 or 9/2. 1 over 9/2 is the reciprocal of 9/2, which is 2/9, and we're negating it. So I get negative 2/9 for the value of c. Let me just run that through one more time for you. Negative 1/2 plus 2 is 3/2, 1.5. Squared gives me 9/4. Times 2 is 18/4, or 9/2. 1 over something means the reciprocal of that something. So this was a 9/2 down here. So the reciprocal of 9/2 is 2/9, and we're negating that. So c is equal to negative 2/9. So we come back down here, negative 1 over 2, y plus 2 squared equals 2x squared minus 2/9. Now, we did one problem earlier where we had a 1 over something, and we found it easier to go ahead and put this together as a single fraction. Then we can just reciprocate both sides, flip both sides. So I'm going to do that. Let's first of all, before I do that, I'm going to go ahead and negate both sides. So I'm just going to get a positive 1 over 2 y plus 2 squared equals, it's going to be 2/9 minus 2x squared. So we'll go ahead and handle the right side. Put this over 1. So we can multiply the top and bottom by 9. So if I do that, I have a common denominator. So I have 2 minus 18x squared over 9. Now we can go ahead and flip both sides. So I get 2 times y plus 2 squared is equal to 9 over 2 minus 18x squared. Divide both sides by 2, or better yet, let's just multiply by 1/2. So I have y plus 2 Multiplying by 1/2, I'm just going to distribute that 2 right across the denominator. So I get 9 over 4 minus 36x squared. And this should be squared back here. Now we take the square root. So we get y plus 2 equals. Now again, we have to consider, is it going to be the positive square root of 9 over 4 minus 36x squared? Or is it going to be the negative square root of 9 over 4 minus 36x squared? And the answer is, if I plug in 0, which one of these gives me a y value of negative 1/2? So let's just try that. Let's plug in 0. That gives me 36 times 0 is 0. 4 minus 0 is 4. So I get the square root of 9/4, which is 3/2. And negative 1/2 plus 2 is 3/2. Over here, we would have gotten negative 3/2. And negative 1/2 plus 2 would not be negative 3/2. So we want the positive version over here. So I'm going to come back up here, and I'll draw myself a nice little line. So we get y plus 2 equals the square root of 9 over 44 minus 36x squared. And let's take away 2. So I get negative 2 plus. There are several things you can do here, if you would like. We could say that the square root of a fraction is the square root of the top divided by the square root of the bottom, so that could just give us a regular 3 up the top. On the bottom, we could factor out a 4 and then take the square root of the product. And so there's several different steps we can do, but this is fine just the way that it is. So now we need to ask ourselves, what's the domain of this function? Well, again, we need to make sure that A, the denominator is not 0, and B, we need to make sure that this entire radicand stays positive because we can't take the square root of a negative number here. So we need to ask, when is 4 minus 36x squared not only not 0, but if this was negative, it would turn the whole thing negative. So we want this to be greater than 0. That happens when negative 36x squared is greater than negative 4 by subtracting 4. Dividing by negative 1 is going to swap the inequality. Dividing by 36 gives me 4 over 36, which is 1/9. And then take the square root. So when we do the square root of both sides here, I get that x is less than 1/3, or x is greater than negative 1/3. So we actually get, if we could merge those, we get the fact that negative 1/3 is less than x is less than 1/3. And since that is a continuous domain here, then that domain is sufficient for our function here. And that's 27.